Good morning. I'm here back with you for our second week of virtual learning. And today we are doing lesson 22. So you're going to need to have out your problem set, your math binder. Make sure you have a pencil. And if you need a multiplication chart or anything like that, you might not even need that today. So, good morning, everyone that's here with me live. Don't forget that throughout my lesson, you can stop and pause. And if you're rewatching the video after the fact, you can do the same thing. So we're going to jump right in. We're comparing the size today of the product, which is the answer when we multiply, to the size of the factors, which are the numbers that we multiply. Okay, so if you look at number 1 on your problem set, it wants us to solve for the unknown. So we have missing numbers that we have to figure out. We're going to rewrite to circle the scaling factor and the number of meters. So the scaling factor is what we're changing the amount by. So in the first one, 1/2 as long as 8 meters. We have 8 meters, so I'm going to put a box around 8. I'm finding half as much as that. So we're going to circle that because that's the scaling factor. Okay? So if I want to find a half of something, remember that of means multiply. So we would rewrite this as 1/2 times 8. What would we get there? Well, 1 times 8 over 2 would be 8 over 2. And how many times does 2 go into 8? 8 divided by 2 is 4. So this is our multiplication expression. And then I want to fill in the missing number. Okay? So I started with 8 meters. The product I got was 4. So what happened to the 8? Did the product get bigger? Did the product stay equal? Or did the product get smaller? Right. This product is smaller than my original 8 meters that I had because I'm multiplying by a fraction. So let's see if the same thing happens over here in the next one. We have 8 times as long as 1/2 meter. Okay. So I'm starting with 1/2 meter. So that's my measurement. Okay. My scaling factor, how much I'm changing it by, is 8. 8 times as much as 1/2. Okay. So I'm going to multiply again. 8 times 1/2. And you might have already noticed that this really is the same multiplication expression as we already solved because multiplication is commutative and we can change the order of the numbers. So this is also going to be 4 meters. But look at what happened. My original measurement was only 1/2. Now we have 4. 4 is bigger. The reason that 1/2 got bigger, even though we did the same multiplication, is because we were multiplying it by 8. So here I multiplied by a fraction that was less than 1, and my product got smaller. Here I multiplied by something that was bigger than 1, and my product got bigger. Okay? Let's take a look at a tape diagram that will explain this a little bit better also. For the first one, we're finding 1/2 of 8. So the total we have is 8. I just want to cut that in half because I'm finding 1/2 of that. Okay. So we took what we started with and we just cut it in half. Whereas if we look at the bottom one, we don't know the total yet, but we're doing 8 times. So I need 8 parts. Each section is worth 1/2. So we're doing 1/2 8 times. So we're repeating that 8 times. So this is getting bigger, where this one, the total was getting smaller. So the important thing to remember here is when you're multiplying by something that is less than 1, your product will get smaller, okay? If you multiply by something more than 1, your product will get bigger. If you multiply by something that's equal to 1, we know from last week that the value will stay the same. When we multiply by 1, things don't change. Okay, so we're going to move on to part 3. Okay, so they're giving us an expression that has a missing number, and we have to find a number that will fit in there. So the first one is 7 times something fourths is less than 7. Okay. So we have to think about what our comparison sign means. This is the bigger side. So we want this side to equal something that is less than 7. So if I want to get something that's smaller than 7, I have to think about what the fraction would look like. So I'm going to think back to what I just did in part 1. If I multiply by something that's larger than 1, this will get bigger. That's not going to work for me. I have to multiply by something that is less than 1 so that it will get smaller. So if I put a 4 here, that would equal 1. So to make this sentence correct, I can put anything here that is less than 4. So I could put 3/4, 2/4, or 1/4. Any of those numerators would make this part less than 7. Okay. Let's look at part B. I'll use another color here. For part B, we have 7 over something times 15 is greater than 15. Okay. So I need this side of my expression to be bigger than 15. So this has to be 16 or higher. So if I want to make this number bigger, think about what should my fraction look like? To make a number bigger, we have to multiply it by something that's greater than 1. So in order to make this fraction greater than 1, the denominator is going to have to be less than 7. Because if I did 7 over 7, that would equal 1, and it would stay the same. It would be equal to 15. So this has to be something smaller than 7. So it could be 1 through 6. So let's say I did 7 halves. This would be more than 1 whole because 2 goes into 7 3 times. So that would be 3.5 times 15, which would be higher than 15. Okay, one more for part C. Three times something fifths equals 3. Okay. So in this situation, we're looking for something that is exactly the same as 3. So if I'm starting with 3, think about what kind of fraction I would want to multiply by. Think back to last week when we were multiplying by fractions that were equal to 1 whole. We talked about, it's even here on my poster, about how when we have the same number on the top and the bottom, that's equal to 1 whole. So this would equal 5. Because 5 fifths is equal to 1. So 3 times 1 would equal 3. Okay? So again, if you want your number to get smaller, you multiply by a fraction that is less than 1. Okay? So that means you would have to have a bigger number on the top than on the bottom. If you want your number to get bigger, you have to multiply by a fraction that is greater than 1. Those are those top-heavy fractions where you have a larger numerator than a denominator. And then if you want it to stay equal, you multiply by a fraction that has the same numerator and denominator. Okay? So I am going to have you guys pause and solve for 4A and 4B. There are 3 parts for each of them. Go ahead and solve those, and then when you come back, I will go over the answers for those. So go ahead and try those out. Okay, so let's go over 4A and 4B. So in 4A, I'm trying to find something that is going to make this side greater than 3/4. I'm starting with 3/4 over here, so I want to make it bigger, so that means I need a fraction that's going to be more than 1. So I might do something like 6/4. You can use any numbers. You don't have to have the same numbers as me, but what you do have to have is a numerator that is larger than your denominator, okay? If this top number is not bigger, this statement will not be correct. Okay, let's look at the next one. We had 2 on this side. I like to start with the side that doesn't have something missing. So this side has to be bigger than 2. I'm starting with 2, so it's the same situation as up here. I need a number that is bigger than 1 to multiply by. So I can use any number. Let's say I could do 20/5. And that is going to make this number greater than 2 because 20/5 is worth way more than 1 whole. Finally, for 4A, I've got 7/5 over here by itself. This side needs to be bigger. So I have to multiply 7/5 times something that has a larger numerator than denominator. Again, you can use any numbers that you want as long as the numerator is larger. Okay, so 4A, all 3 parts, we were increasing the value of our factor by multiplying by a fraction that was greater than 1. Let's go over to 4B. I have 3/4 here. This side has to be smaller. So what can I multiply 3/4 by that will decrease the value and make it smaller? It's got to be something that is basically the opposite of what we did here. Instead of having a larger numerator, now we need our smaller numerator. So any numbers where the top number is smaller. So I could do 3/4. That would work. You could do 10/20. As long as that numerator is smaller than the denominator, the value of the first factor will decrease. Let's look at the next one. I have a 2 over here by itself. This has to be the bigger side. So how can I make this 2 smaller? Same thing, multiply it by something less than 1. So I need a smaller numerator, so maybe 3/7. That's less than 1, so this side will be less than 2 wholes. And then finally we have 7/5, and I need this side to be less than 7/5. So to make 7/5 smaller, again, we are going to multiply by a fraction that is less than 1. So our numerator is smaller than the denominator. So maybe 6/10. You can use any numbers you want as long as that numerator is smaller. Okay, so to sum it up, if you want your product to be larger than the factor, multiply by a fraction that is greater than 1. If you want your product to be less than the factor, multiply by a fraction that is less than 1. Okay, so thanks for tuning in. Go ahead and practice a couple more of these on your problem set. And then when you're feeling ready, go ahead and do your exit ticket that's posted on your classroom page. Have a great day.